In a certain parallel resonant bandpass filter, the resonant frequency is 14 kHz. If the bandwidth is 4 kHz, the lower frequency A is 7 kHz, B is 10 kHz, C is 12 kHz. D cannot be determined. The correct answer is 12 kHz. An RL low-pass filter consists of a 5.6 mH coil and a 3.3 K resistor. The output voltage is taken across the resistor. The circuit's critical frequency is A 93.8 kHz, B 93.8 Hz, C 861 Hz, D 86.12 kHz. The correct answer is 93.8 kHz. In a series resonant bandpass filter, a lower value of Q results in A higher resonant frequency, B a smaller bandwidth, C a higher impedance, D a larger bandwidth. The correct answer is a larger bandwidth. The maximum output voltage of a certain low-pass filter is 15 V. The output voltage at the critical frequency is A 0 V, B 15 V, C 10.60 V, D 21.21 V. The correct answer is 10.60 V. A parallel resonant bandpass filter consists of a 90 resistor in series with a parallel network made up of a 60 mH coil and a 0.02 F capacitor. The output is taken across the capacitor coil. The coil winding has a resistance of 20. What is the center frequency of the filter? A 459 Hz, B 591 Hz, C 999 Hz, D 176 Hz. The correct answer is 591 Hz. An RL high-pass filter consists of a 470 resistor and a 600 mH coil. The output is taken across the coil. The circuit's critical frequency is A 125 Hz, B 250 Hz, C 564 Hz, D 644 Hz. The correct answer is 125 Hz. A parallel resonant bandpass filter consists of a 6.8 resistor in series with a parallel network made up of an 8H coil and a 120 pF capacitor. The output is taken across the capacitor coil. Assume RW0. What is the center frequency of the filter? A 5.14 MHz, B 514 kHz, C 5.03 MHz, D 503 kHz. The correct answer is 5.14 MHz. A series resonant bandpass filter consists of a 2 mH coil, a 0.005 F capacitor, and a 120 resistor. The winding resistance of the coil is 12. The output voltage is taken off the resistor. Input voltage is 12 vrms. What is the output voltage magnitude at the center frequency F0? A 10.9 V, B 1.09 V, C 1.1 V, D 12 V. The correct answer is 10.9 V. An RC low-pass filter consists of a 120 resistor and a 0.002 F capacitor. The output is taken across the capacitor. The circuit's critical frequency is A 333 kHz, B 633 kHz, C 331 kHz, D 60 kHz. The correct answer is 633 kHz. Referring to problem 15, if the input voltage is a 6 V sine wave with a DC level of 10 V, what is the output voltage magnitude? A 6V, B 597 MV, C 5.97V, D 0V. The correct answer is 5.97V. In a certain low-pass filter FC 3.5 kHz, its passband is A 0 Hz to 3.5 kHz, B 0 Hz, C 3.5 kHz, D 7 kHz. The correct answer is 0 Hz to 3.5 kHz. An RC high-pass filter consists of an 820 resistor. What is the value of C so that Xc is 10 times less than R at an input frequency of 12 kHz? A 81 floor, B 161 floor, C 0.161 F, D 220 floor. The correct answer is 0.161 F. A series resonant band stop filter consists of a 68 resistor, a 110 mH coil and a 0.02 F capacitor. The internal resistance Rw of the coil is 4. Input voltage is 200 mV. Output voltage is taken across the coil and capacitor in series. What is the output voltage magnitude at F0? A 1.1 mV, B 11.1 mV, C 111 mV, D 200 mV. The correct answer is 11.1 mV. A sinusoidal voltage with a peak-to-peak value of 18 V is applied to an RC low-pass filter. If the reactance at the input frequency is 0, the output voltage is A 18 V peak-to-peak, B 0, C 9 V peak-to-peak, D 12.74 V peak-to-peak. The correct answer is 0. V out 500 mV and V in 1.3 V. The ratio V out V in expressed in dB is A 0 dB, B 8.30 dB, C 8.30 dB, D 0.8 dB. The correct answer is 8.30 dB. At a certain frequency, the output voltage of a filter is 6 V and the input is 12 V. The voltage ratio in decibels is A 6.02 dB, B 6.02 dB, C 12.04 dB, D 12.04 dB. The correct answer is 6.02 dB. An RC high-pass filter consists of a 0.2 F capacitor and a 220 resistor. The output is taken across the resistor. The circuit's critical frequency is A 723 Hz, B 234 Hz, C 362 Hz, D 617 Hz. The correct answer is 617 Hz.